The 3 points we have to see. So now you will get this. Okay, now you will get in the YouTube. Okay, f of x equals to mod x plus mod x minus 1 plus mod x minus 2 at x equals to 0, 1 and 2. Okay, so now first we'll see at point 0. So you write at x equals to 0. So continuous, no, continuous, it is related with the limits. So first one is RHL. RHL is equals to limit x tends to 0 plus f of x. So limit we convert into h tends to 0, h greater than 0. Next, in place of x, we have to write 0 plus h. That is 0 plus h plus 0 plus h minus 1 plus 0 plus h minus 2. Okay, you are able to see. So now it is equals to limit h tends to 0, h greater than 0. If any simplifications are there, you can do that. It will become mod h. It is mod h minus 1. It is h minus 2. Okay. Now in place of h, you substitute 0 value. So first one is 0. Next here 0 minus 1. Minus of modulus is plus 1. 0 minus 2. So minus 2 of modulus is plus 2. So we'll get the answer as 3. Okay. This is about RHL. Now if you'll see LHL, it is equals to limit x tends to 0 minus f of x. So it is limit h tends to 0, h greater than 0. In place of 0 plus h, you write 0 minus h. Minus h plus 0 minus h minus 2. Okay. Now when you simplify this, it is minus h. It is minus h minus 1 plus minus h minus 2. Now in place of h, you substitute 0. So 0, this is 0 minus 1. So plus 1 and minus 2 will become plus 2. Okay. If you want, you can write one more step by taking out this as minus plus h, and after that you can substitute. Okay. Directly if you substitute h value, you will get these. So both values are same. Therefore, you can write therefore RHL is equals to LHL. Thus, f of x is continuous at x equals to 0. Okay. So this is the procedure. If one value is given or two values are given or three values are given. But by taking those value here and substituting here that value, it's important. If you change those two values, you will get different answers. And one thing is, remember that whatever value you are getting, you have changed that one here. If you, this is 0, but you will not get confusion here. Instead of 0, if you have 1, what you will write here? 1 plus h, 1 plus h, 1 plus h. And in next step, compulsory h value, you have to take 0, not 1. Don't get confused in these two values. Here already you have converted into the whatever the point is there, that point. Here h value is always 0 only. Okay, remember that. Now we'll see for at x equals to 1. At 1 plus, so this is 1 plus h, 1 plus h, 1 plus h minus 2. Here 1 and 1 minus 1 both will get cancelled. So here you will get it as 1 plus h. Next only h plus h minus 1 you will get here. Now what you will get? 1 plus 0. So this value is 1. H is 0.
In exams, we have to substitute all the three numbers, ma'am. 0, 1, 2. Only you can substitute only 0 or 1 or 2.
No. At 3 points, you have to find the values.
Okay.
So if such problems are given, means they will ask for the 10 marks question. Why? Because it is asked for 3 points, no? So if it is only for the 2 points or only 1 point, you might be getting for 5 marks questions. Okay.
Okay.
So if you have like this at the, because at 0, whatever the procedure is there, it is same as for the 1 and also at the point 2. So it will be 10 marks question. But at the 3 points, you have to find all the values. But For 0, you will have some other value. For 1, you will get some other value. For 2, you will get some other value. Okay, you will not get all the 3 values same. It will be changing, no?
Okay, ma'am.
Okay, remember that one. So
Okay,
here, -1 we got cancelled. No, here only h is there, and here h minus 1. So this is 1, and this is 0. Here this is 1. So here see this value is 2. Okay. Next, if we'll go to the LHL, 1 minus, this is 1 minus h, 1 minus h, and this is 1 minus h. Here also cancel out 1 and -1. So what you'll get here, 1 minus h, and this is only minus h, and this is minus h minus 1. So now if you substitute the 0, this is 0, this is 1 here, this is 0, and this is 1. So we'll get the answer as 2. Okay. So just you substitute h values as 0. Don't do again simplification. If you go to the simplification, you may get some confusion. So directly substitute the h value as 0. So whatever it is left, you take that values. Here 1 is left, here 0. Here if you take out 0, it is -1. Modulus of -1 is +1. So 1 plus 1 is 2. Okay. Okay, sorry. Here one step we have missed this one. Before writing this sentence, for continuity, only LHL and RHL should be not be there, no? Even f of, okay, here you see, before one, not this one, before problem at x equals to 0, RHL should be equal to LHL, and that value is 3. And one more point is what? F of 0 also we have to find. What is that f of 0? In place of f of x, substitute the 0. That is 0 plus 0 minus 1 plus 0 minus 2. So what you'll get here? This is -1. So plus
1.
-2 plus 2.
3.
Equals to 3. So now, since limit extends to 0, f of x value is equals to 3 is equals to f of 0. Therefore, f of x is continuous at x equals to 0. Okay, these steps we have missed. Compulsory f of 0 should be there. Why? Because what is the definition of the continuity? Continuity definition is limit extends to a, f of x should be equal to f of a value. Okay, so that's why f of 0 value also we got 3. So these two values and these two. So right like this. What happened?
Excuse me, mute.
Please mute the device. Okay. So at x equals to 1, we got 2, 2. Here also same. RHL is equals to LHL is equals to 2. So, and what we got, what will get one value, f of one value is this is 1. This is 1, this is 1 minus 1, this is 1 minus 2. So 1, this is 0, and this is 1. So you'll get it as 2. So this value is 1 and this value is 2. So therefore limit extends to 0, f of x equals to 2 equals to f of 1. So f of x is continuous at x equals to 1 value. So similar way, so we have seen for x equals to 0 and x equals to 1, you can see at x equals to 2 also. Here 2 plus, so this is 2 plus h, this is 2 plus h, and here also 2 plus h. So this is 2 plus h, and here you'll get it, this is 1, this 2 and minus 2 will get cancelled. This is h plus 1. So h 2 minus 1 is plus 1. Here what you get? Only h. So here 2 plus 0. So 2 plus 0 means here 2. And this is 1. And this value is 0. So this value is 3. At x equals to 2, you will get the value as 3. And similarly, LHL value 2 minus This is 2 minus h. 2 minus h. This is minus 1. And here 2 minus h minus 2. So this 2 and this 2 will get cancelled. So we got here 2 minus h. And this is minus h plus 1. And here only minus h. So this is 2 minus 0. So you'll get the value as 2. And this is 0 plus 1. So you'll get 1. And this is 0. So the value is here 3. Okay. So RHL equals to LHL is equals to 3. And f of 2 value. F of 2 value is, this is 2. This is 2. This is 2 minus 1. This is 2 minus 2. So this is 2. This is 1. And this is 0. So you'll get the answer as 3. So f of 2 value is 3. Therefore, f of x is continuous at x equals to 2. Okay. So at last you write, therefore the given function f of x is continuous at x equals to 0, 1 and 2. So this is the stepwise how to solve the problems given like this. So this is the MEQ question, that is a model examination questions will be there. No, at the completion of the unit you will have. From that I have taken this one. So procedure is the same one. If 1 point is given or 2 points are given or 3 points are given. Okay. So this is the concept above the continuity. So by this we are completing the unit 1. So unit 1, almost question on limits is there. No, examine the limits, that is a limit exist or not, that question you will get, or the continuity question you will get. So this one, 2 topics are important in first unit. So if you have textbook, so try to open that. I will give important questions in first unit. So all are having the textbooks, sir. So if we have, or else you write the page number. Okay. So page number 4, 1.2.3 theorem is there. This is the important theorem. Just write down the page number and that exercise numbers. Okay. In the notebook you write page number 4, 1.2.3 theorem. If the limit of a function f exists at a point A, then it is unique. And check your progress is there, page number 5. 1, check your progress 1. This problem I have already told for you. Okay. After that, page number 6, 1.2.12. 1.2.12. Page number 7, 1.2.15, 16, 17. So in this you will get objective type questions also. Next, page number 13, 4 and 5 question. Page number 14, you have the definition of the continuity of the function. That is 1.4.1, 1.4.2, 1.4.3. These you will get for the objective type. Next, 17, page number 7th question. So that you will get for 5 marks question. And page number 19, theorem is there, 1.5.4, 1.5.5. These 2 are the important, and first one I have told now, these 3 are the important theorems you may get for the 10 marks questions. That is a 9th A question you will get. And page number 23, 9 and 11. These 2 are important, 9 and 11. So for this you have the solutions on the 25th page number. Check your progress is there now. So for those problems you will have the solution in the textbook itself. So try to write all these problems in your notebook, and at the time of examination just you once glance it, then you can solve those all problems. Okay. Next we will go to the second unit. Second unit is the differentiability of a function. So we have seen the definition of the what is the differentiability of the function or the derivative of a function. Both are the same one. So whatever you will get the f dash of x, that is called as the derivative of the function. Okay. So just you remember the formula for the differentiation. That is, if you remember this, enough for you. Limit extends to c, f of x minus f of c by x minus c. So it is called as the first principle. And also remember this one. It is first principle of derivation. So some problems will be asked for finding the derivation of any function with the help of the first principle. That is, limit extends to c, f of x minus f of c by x minus c. We call it as f dash of c. Okay. And whenever it is RHD, it is equals to r f dash of c. It is equals to limit extends to c, f of x minus f of c by x minus c. So if you convert this one into limit h tends to 0, we'll write in place of this f of c plus h minus f of c by here. If you substitute c plus h minus c means c will get cancelled, you'll get h here. Okay. Whenever it is a LHD is L f dash of c equals to, I'm writing this one. Okay, that is same. Limit h tends to 0, f of c minus h minus f of c by, in the denominator here c minus h, no, c will get cancelled, minus h will be remaining. So here you will get minus h. So remember these two formulas. These two are important for solving the problems. So whenever RHD is there, c plus h will be there, in the denominator positive h. Whenever LHD is there, c minus h, in the denominator minus h. Okay. If these two are equal, then the whatever the function is there, then it can be differentiable, or it is you will get the derivative of that function. So some problems will be there direct with the help of this formula only. We can find the derivative of those functions. That is a derivative of x square, x to the power of n, or sin x or cos x, like that functions will be there. No, that you can find with the help of this one. So this one is useful for the functions like that. Modulus of the functions will be there. No. So for that function, both RHD and LHD should be same. If they are same, then the function is differentiable. Okay. So first you remember these two. And after that you have the properties are there. Whatever the properties we have seen for the continuous of the function. Same one, that is the, if it is a constant function f of x equals to c. If it is identity function, that is, these all are differentiable functions. Equals to x is equals to sin x is equals to log x or e power x or any polynomial. 1, 2, 3, 4, 5, 6. So these 6 type of functions are always differentiable functions in their domains. Okay. These are continuous and also these are differentiable function. And one more theorem is very important in this unit, unit 2. It is that every differentiable function is continuous. Okay. Every differentiable function is continuous, but the converse of this theorem is not true. That is, every continuous function is not differentiable. Okay. So if this function, if this is both continuous and differentiable, it is applicable for this one. But if you take the example of the function like this, if it is equals to mod x, okay, this is continuous, but not differentiable. Okay. If a function is there, it is differentiable, means compulsory it will become the continuous function, but it need not be there if it is a continuous function. If it is, see the first theorem, that is, if any differentiable function is continuous, but every continuous function is not differentiable, that is the converse of that one. So question they will ask that, show that every differentiable function is continuous, but the converse of the theorem is not true. You justify it with the help of any example they will ask. The best example for this one is mod x. For the mod x, you can show that it is continuous, but it is not differentiable. Okay. So that theorem is the important theorem. You might get it for the 10 marks question. That is a 9th B question you will get. So that theorem you have on the, so definition is there on page number 30. You have page number 30, 2.2.2. So theorem is on page number 34 and 35. 2.2.11, 2.2.12. So theorem is this one. If f is derivable at a point, then yet it is continuous at that point. So this is the proof of the theorem. And second part, if he's asking the example with the help to prove, means example is given here. See, f of x equals to mod x. See the remarks also, you will get this one. The converse of the above theorem is not true. That is, if a function is continuous at a point, it need not be differentiable at that point. Okay. So this is the 10 marks question. Before that, we'll see all the formulas are there. So formulas are very important in the differentiation. In second unit, all the formulas, that is d by dx of x or d by dx of a constant, that is c. What is the value of that one? All that proofs are given in your textbook. You will see once the textbook, what is the d by dx of sin x or cos x, tan x, that all are given in the textbook. So you already have learned in the intermediate, that is d by dx of x is 1, d by dx of c is 0, d by dx of sin x or cos x, those all values. So those all values we get with the help of the first principle. So one problem they will give on first principle, that is, so question will be like this: f of x equals to x square, x belongs to R. If f of x equals to x square, x belongs to R, then find f dash of a. Okay. So then find the value of f dash of a where a belongs to R, real numbers. Okay. So this is the one important question. This you have to find with the help of y, because x square is a polynomial you have. So this is already the continuous function and also it is a differentiable function. So we know that one. So directly with the help of the first principle, if you solve this one, it's enough. So for this, you see f dash of is asking to find f dash of a, but here x is there. That means here the point is at x equals to a. So in some other you will get x equals to 0 or x equals to 1 or 2 like this. Here the point is at x equals to a. So f dash of c will write now. Here c value is a. So f dash of a equals to f dash of a plus 0. First principle means a plus 0. So no need of writing this one. This f of a plus 0, no? Okay. Here you write h, you will get the confusion. A plus h, 0 plus h, no? If it is 0 means 0 plus h or c plus h, like that. So it is equals to limit h tends to 0, f of, in place of x, we are writing a plus h. So a plus h minus f of a by h. F of x minus f of c by c, you will get, no? X minus c. Same like that only. F of c plus h minus f of c by h. Here in place of c, we have a plus h minus f of a by h. Now limit, what is f of a plus h means, here you substitute a plus h. So you'll get it as a plus h whole square minus f of a. F of a means a square by h. So it is equals to limit h tends to 0. It is in the form of a plus b whole square. So a square plus h square plus 2ah minus a square by h. So a square will get cancelled. H square plus 2ah by h. Limit h tends to 0. Okay. Now if you substitute the h value as 0, what will happen? You will get 0 by 0 form. So to avoid that one, first take out the h common. If you take out h common, h plus 2a by h. So h will get cancelled. Now substitute the h value as 0 here. So you will get 0 plus 2a equals to 2a. So we already know x square differentiation is 2x. In place of x, we are taking a. So the answer is 2a. So therefore, you can write f dash of a is equals to 2a. Okay. So this is the method of finding any differentiation of the given function with the help of the first principle. And one more thing is there, directly also you can find, you have converted this into H form now, or we can write like this also. That is f dash of a equals to limit extends to a f of x, direct from the formula f of a by x minus a. Okay, it is a direct formula now without using the h. Limit extends to c. C in place we are writing a, f of x minus f of a by x minus a. What is our f of x? X square. If you substitute in x square, a means a square by x minus a. It is equals to limit extends to a. It is in the form of a square minus b square. So it is a plus b into a minus b by x minus a. Both will get cancelled. So we'll get it as limit extends to a x plus a. Now substitute the x value as limit. What is the x value? A. So a plus a is 2a. So like this you can find, this is the one procedure, or else you can find like this. So this is the converting it into H form directly with the help of the formula also you can find this one. Okay. Two methods are there. You can use any method. You will get the same answer. Okay. So this is the problem on first principle. Now we'll see the some of the definition, that's the formulas of the different functions. So if you know these all, these are very important in solving the second and third unit, and also even in almost 4 blocks. So differentiation is there, no differential calculus, our semester mathematics name itself. So differentiation will be there. So if you know the differentiation of all the functions, they are useful for solving the problems. So first you remember this one, trigonometric, some identities will be there, no? First you see this. Trigonometric identities, okay? So first you remember this one, this tan theta equals to sin theta by cos theta. Cot theta is equals to cos theta by sin theta. Secant theta is equals to 1 by cos theta. Cosecant theta is equals to 1 by sin theta. And what we have after this, cot theta. And we can write cot theta is equals to 1 by tan theta also. This also you remember. And again these formulas, sin square theta plus cos square theta is equals to 1. And secant square theta minus tan square theta is equals to 1. Next, cosecant square theta minus cos square theta equals to 1. Eighth one, sin 2 theta is equals to 2 sin theta cos theta. Sin 3 theta is equals to 3 sin theta minus 4 sin cube theta. Okay. 10th one, cos 3 theta equals to 4 cos cube theta minus 3 cos theta. Okay. Next. So why I have not written here cos 2 theta means cos 2 theta, 4 formulas are there. We'll see in the upside that one. 11th one is the, till here it's enough, we'll go to upside. Okay. These all identities are important for solving the any differentiation problems. And sin 2 theta in terms of tan also we can write this one. This is also useful in writing the problems. Okay. In solving the third unit, it is very important. 2 tan theta by 1 plus tan square theta. Okay. Next, cos 2 theta also we can write in tan 1 minus tan square theta 1 plus tan square theta. Okay. 13th one, tan 2 theta itself. tan 2 theta equals to 2 tan theta by 1 minus tan square theta. Okay. Now we'll go to cos 2 theta. Cos 2 theta is cos square theta minus sin square theta. And also 2 cos square theta minus 1 minus 2 sin square theta. Okay. These are the different formulas are there for cos 2 theta 3. And even fourth one, this one in terms of tan. Okay, you remember these all trigonometric identities. These are very important. And we'll go to the differentiation formulas. So differentiation formulas are for all the, many are there, trigonometry functions are there. And also next hyperbolic functions are also there. Hyperbolic means instead of here sin h, we will write it as sin hx. Okay, h represents here hyperbolic function. So these identities you have to remember compulsory for solving all the differentiation problems. Next, if we'll see all the differentiation problems, that is d by dx of any constant function, it is 0. Okay, d by dx of any x to the power of, which is in the form of x to the power of n into x to the power of n minus 1. And d by dx of 1 by x, if you have, it is minus 1 by x square. Same, d by dx of root x is 1 by 2 root x. Okay. And next, d by dx of log x is 1 by x. D by dx of e power x is e power x only. And one more you can see here, if it is e to the power of 2x, you have to write like this, 2 into e to the power of 2x. Okay. Next, if you'll see the sin x and log x, we have seen a power x will be there. A power x is a power x log a. Okay. With the help of the first principle is there, no? First principle of the differentiation, you will get these all answers. Okay. So a power x equals to a power x log a. Next, if we'll see the sin x is equals to cos x. And remember one thing, if you have in the form of sin 2x, first sin 2x differentiation is cos 2x. Okay. And here 2x is there, no? If single variable is there, here only x is there. So x variable, x variable differentiation is 1. So we are not writing here 1. Actually, it is like this, into 1. Okay. Here cos 2x is there. That means sin 2x differentiation is cos 2x. 2x differentiation is 2 you'll get. You are writing here that one. Okay. That is 2 into cos 2x. If we have 3x, 3 into cos 3x. Nx means n into cos nx. Okay. So these all are useful for solving the problems. Next, if we'll see the cos x, it is minus sin x. And the 12th one, tan x is secant square x. So these all formulas compulsory you have to remember. Here d by, in this is also, you remember this one, d by dx of x value is 1. Constant value is 0. Only if x variable is there, means that value is 1. Okay. Why? Because you just apply here. Here power 1, no? 1 into x to the power of 1 minus 1, 0. X to the power of 0 is 1. So the value is 1 here. Okay. You can find like that only x square, x cube, x to the power of 4, any values with the help of this formula. So this formula is important one. Next, if you see the tan x, no? After tan x, cot x equals to minus cosecant square x. Next, if we see the secant x is secant x tan x. These all, whatever the proofs are there, you have in your textbook, you can see there. Minus cot x, cosecant square, cosecant x. Next to 16th one, sine inverse x. Sine inverse x is 1 by root of 1 minus x square. These inverse trigonometry, these are called as inverse trigonometric functions. So, okay, these are also very important. If you see the cos inverse x, you will get here just a negative sign, 1 minus x square. So, tan inverse x is 1 by 1 plus x square. Sine and tan both you will regularly will use in solving the problems. Okay. 19th one, cot inverse x. Just you will have the minus sign here. And secant inverse x, 1 by mod x under root of x square minus 1. If you see the cosecant inverse x, minus 1 by mod x under root of x square minus 1. Okay. Almost I have covered all the formulas. These are the trigonometric functions. These are the inverse trigonometric functions. Next unit, we have the hyperbolic functions are there. Hyperbolic functions means instead of x, we'll write as hx. Even you remember these also. Sin hx, we can write it as e power x minus e to the power of minus x by 2. This proof is also there in your textbook. How you got this? So this differentiation of sin hx is cos hx. And this cos hx will write in exponential function as like this, e to the power of minus x by 2. Okay. And d by dx of cos hx is not minus sin hx, only sin hx. Here cos hx differentiation is minus sin x. But here in hyperbolic function, you will get the positive one. Okay. And after this, again, tan is also there, cot, secant. Okay. So for all hyperbolic functions also, you have formulas in your textbook. I'm not going into that. It will take more time. So those all formulas you can collect from the textbook. And one thing you remember this one, that is cos h square x minus sin h square x equals to 1. There we got plus, no? Here if we'll get the minus. And one more is 1 minus tan h square x is equals to secant h square x. And one more is cot h square x minus 1 equals to cosecant h square x. And even for hyperbolic functions also, you will get the like this inverse trigonometric functions. Inverse hyperbolic, that is in place of x you will have hx. So inverse hyperbolic trigonometric functions. For that also you will have the formulas. So some important I have given. So other formulas you collect from the textbook. Those formulas you will get for the multiple choice questions. So objective type also you will get, and also for solving the problems also you will get. Okay, next, the properties of the derivatives are there. This is the important one. So if you know the properties of the derivatives, you can do the problems easily. Okay. So here, if any two functions are there, if they are differentiable, means already they are differentiation, means when you add them or subtract them or multiply or division, then you will get the same derivatives. That means that whatever the function is there, that function is the derivable function. And the formula for finding the derivative of such functions is d by dx of u plus or minus v. U is one function, v is another function. Then we can write it as d by dx of u plus or minus d by dx of v. Like this, we can separate it. Okay, that is just u dash plus or minus v dash. Okay. Next, if we take d by dx of u into v, this is called as uv rule or product rule. Okay. So this will be for the product rule. One thing is two functions are there. So two functions, one function you have to keep constant, and next function you have to do the differentiation. Okay. That is you take outside and dv by dx plus v into du by dx. So that is u into v dash. Okay, this is called as a UV rule or product rule. Next one is d by dx of u by v. This is u by v rule, or we call it as a quotient rule. Okay, quotient rule or u by v rule, anything. Okay, so this is, you remember this one, whatever in the denominator is there, that square into same one, that constant into du by dx minus u into dv by dx. This is the formula, that is v into u dash minus u into v dash by v square. Okay, so these three are very important one. This one and this one will use, this is nothing but just you are separating the two and you are writing in between plus or minus, but this one and this one both are important. Here you got negative sign, here you got positive sign, and just interchange of those, this one minus this one by v square. Okay, for solving the problems, these two are very important. And we'll see the problem on this one, differentiation. Okay, next we have the problem. Show that the function x into mod x is differentiable at x equals to 0. Okay. Show that the function x into mod x is differentiable at x equals to 0. It is given in the question itself that it is differentiable. Differentiable means whatever the RHD and LHD values, you should get the same one. Okay. So first we'll find the RHD. RHD equals to f dash of here 0 plus h. So our C value is 0. Okay. So it is equals to limit h tends to 0. F of 0 plus h minus f of 0 by h. Okay. So what is our f of x? Our f of x is x into mod x. So in place of x, you have to write 0 plus h. That is, it is equals to limit h tends to 0. 0 plus h. So this is a multiplication. Modulus you have here 0 plus h minus f of 0 means 0 into 0. This value is 0 by h. So what you'll get? This is h is there, and modulus of 0 plus h is h. So h into h is h square by h. Now you cancel out this, limit h tends to 0 by h. And when you take h value as 0, so the answer is 0 here. Okay. So the RHD value is 0. In the similar way, we can find the LHD also. So LHD, what you'll get? So LHD is, this is 0 minus h 0. This is 0 minus h, f of 0 by, in the denominator you will get minus h. So this is minus h, this is 0 minus h into modulus of 0 minus h by minus 0. So what you will get here, this is minus h, and modulus of minus h is h, and this is minus h. So minus h both will get cancelled, again h will remain. When you substitute h value as 0, it is 0. Okay. So both the values are same. Therefore, RHD is equals to 0 equals to LHD. Okay. Here you can write thus f of x is differentiable at x equals to 0. Okay. So like this, you have to find the solution of the any given problem. So this is the simple one. So this almost they will ask for only 5 marks question. So next we have one more problem. That problem is important for the 10 marks question. here 2 points are given. We have seen the continuity problem now, same like this only. So that the function is not differentiable. Okay, it is given in the question itself that is not differentiable at x equals to 0, 1. So at 0 also it is not differentiable, and also at 1 is also it is not differentiable. Okay, and one thing is you can solve this problem in 2 ways. Means 2 methods are there to solve this one. So first thing is whatever we have solved before problem, like that you can solve. And another one is you can convert this equation. The function is there now, f of x equals to mod x plus x minus 1. Okay, this is the function you have. You can convert this function into 3 forms, 3 different forms with the help of these 2 points. Okay, so first one, what will be there? X, that is LHD and RHD. So x is LHD means it is less than 0. RHD means it is greater than 0. And similarly, x is less than 1, x is greater than 1. So at these 4 points, we have to, the 4 intervals, we have to see the function. So here we can convert this one. When x is less than 0, what will happen? This will be the minus x, and this is minus of, that is x minus 1. This will become negative and this will become negative. Why? Because modulus, when it is less than 0, it will be minus x. So here minus x, and this is minus of minus x. So it is equals to minus x. This is minus x. Minus into minus is plus 1. That is 1 minus 2x. When x is less than 0. Okay. So if you see, when x is greater than 0, this is positive and this is positive. So what will happen? When x is greater than 0, this will become positive. That is, it is x. And here, when x is greater than 0, here the value is positive. But x minus 1 is there. Modulus of x minus 1 means this is minus of x minus 1. So you'll get this as x minus into minus plus 1. So if both will get cancelled, you will get it as 1 when x is greater than 0. Okay. Now, when x is less than 1, when x is less than 1, also you will get the same one. X is less than 1 means this point will be the positive one, and this point will be the, why? Because x minus 1 is there. So minus of x minus 1, same. So these 2 conditions, they will get the same answer. So you can write this as, for 1 less than or, sorry, 0 less than or equals to x less than or equals to 1. Means when x is greater than 0, 1. When x is less than 1, value is also 1. Same you'll get when x is less than 1 means this value is positive value. But this value, because here 1 is there, no? That's why you'll get this value as minus 1. Okay. So for these 2 conditions, this is, that means RHD of 0 and LHD of 1. Value is 1 here. Next, when it is x is greater than 1, both will be positive. That means x plus x minus 1. So you'll get it as x plus x minus 1. It is 2x minus 1 when x is greater than 1. So, okay, this problem you have in that check your progress. In the problem, he has given directly how you got this one. F of x equals to 1 minus 2x, 1 and 2x minus 1. Okay. And just he has given the solution of the problem. Okay. I am telling how you got these values. So for any problem, you can convert like this and you can solve that one. See, we can write here like this. F of x equals to 1 minus 2x when x is less than 0 and it is equals to 1. When 0 less than or equals to 1, 1. And it is equals to 2x minus 1 when x is greater than 1. So like this you have to write. Okay. Now we got 3 functions, 3 different functions at the 2 points. At the 2 points, that is x equals to 0 and x equals to 1. So now with this, we can find the problem. That is a one method. That is for this you can't write with the at x equals to 0 and at x equals to 1. Directly for the, like this you can write. Okay, you take it better if you will get the, for at x equals to 0. So if you will take RHD, R f dash of 0. Okay, at the 0 we are finding. It is equals to limit, I am directly going to h. Okay, f of 0 plus h minus f of 0 by h. So limit h tends to 0. So here RHD means x greater than 0. So here x greater than 0. What is the function? Function is only 1. That means this value is 1 minus f of 0. If you will put f of 0, what is the value? 1 only. So 1 minus 1 by h. So it is equals to limit h tends to 0. 1 minus 1 is 0, 0 by h. Now 0 by h value is what? 0. We are not substituting the h value. Before substituting the h value, you are getting the value as 0. So the answer is here 0. So similarly, this is the RHD, no? If we go to the LHD, L f dash of 0 is equals to limit h tends to 0, f of 0 minus h by f of 0 by minus h. So it is limit h tends to 0. When it is less than 0, the value will change. What is that? When x is less than 0, it is 1 minus 2x. That means our function is here 1 minus 2 into 0 minus h. Okay, minus f of 0, 1 minus 0. So you will get this as 1 by minus h. So limit h tends to 0. This is 0. Minus into minus is plus 2h minus 1 by minus h. So 1 and minus 1 both will get cancelled. You got 2h by minus h. H and h will get cancelled. So constant you are getting, that is minus 2. So limit of any constant is same that value. So the value is minus 2. We got RHD as 0 and LHD value as minus 2. So therefore, RHD equals to 0 is not equals to minus 2 equals to LHD. Okay, therefore f of x is not differentiable at x equals to 0. Okay. Now similar way you can see at x equals to 1. So this is 1 plus h and this is f of 1. So what is f of 1 plus h means x greater than 1. Okay. So x greater than means what is the function? 2x minus 1. 2x minus 1. So 2x means 2 into, in place of x you write 1 plus h minus 1 minus f of 1 minus f of 1 is 2 into 1 minus 1 by h. If you simplify this, 2 plus 2h minus 2, oh sorry, minus 1. Just I am writing this one. At the simplification, I'll write here. So this is 2 plus 2h minus 1 minus 2 into 1 is 2 minus 1 means 1. So it is minus 1 by h. So this what you will get 2 plus 2h and this is minus 2 by h. So 2 will get cancelled. So what is remaining? 2h by h. Okay. So here I am writing the direct one, that is limit h tends to 0. 2 plus 2h minus 2 by h. So 2 will get cancelled. And here if you take limit h tends to 0, 2h by h. So I'll get the answer as 2. Okay. RHD value is 2. Don't get confusion. I'll write here. It will get the 2 into 1 minus 1 by h. So it is limit h tends to 0, 2 plus 2h minus 1 by h. It is limit h tends to 0. This minus 1, this will get cancelled, 2h by h. So you'll get it as 2. Okay. Now if you'll take LHD, f dash of 1, and this is 1 minus h, and this is 1, and the denominator minus h. So when x is less than 1, x is less than, what is the function? Only 1. So 1 means you'll get 1, and f of 1 value also 1. So 1 minus 1 by minus h. So it is limit h tends to 0, 0 by h equals to 0. So what we got the values? So LHD, RHD value is 2, LHD value is 0. Therefore, RHD is equals to 2 is not equals to 0 equals to LHD. Therefore, f of x is not differentiable at x equals to 1. At last you write thus f of x is not differentiable at x equals to 0, 1. Okay. So this is the procedure how to find the problem. You can convert this into like these 3 functions with the help of these 3 values. At a time, you'll get the 3 different functions. If you have any confusion of doing like this problem, directly you can keep the function like this only, and you can solve how we are done for the continuation of the function. Continuity of the function we have done now. So just I'll tell for RHD for this one. You see the LHD and also RHD and LHD of 1. Okay. So that is, if you take at x equals to 0, if the function you are taking is this one, only this one, that is limit x tends to, this is RHD. It is equals to R f dash of 0 is equals to limit h tends to 0, f of 0 plus h minus f of 0 by h. So what is our function? Limit h tends to 0. 0 plus h means modulus of 0 plus h plus 0 plus h minus 1 minus f of 0 means f of 0 means 0 plus 0 minus 1 by h. Okay. So if you solve this, so if you take directly the function, not converting it into 3 forms, so it is equals to limit. So 0 plus is h, and this is mod h minus 1, and this is, you'll get minus 1. Minus 1 is plus 1. This is minus 1 by h. Okay. So this you'll get it as limit h tends to 0. This h is h, and this is less than, no, x is greater than 0 means this is positive, but this you will get as a negative 1, that is minus h plus 1 minus 1 by h. So this will all will get cancelled. You will get it as limit h tends to 0, 0 by h is equals to 0. Okay. In the similar way, you can see even LHD also. See, LHD is L f dash of 0 is equals to limit h tends to 0, f of 0 minus h minus f of 0 by minus h. That is limit h tends to 0, 0 minus h plus 0 minus h minus 1 minus 0. This you will get a minus 1 only. Okay. By minus h. So limit h tends to 0. This is minus h. This is minus h minus 1 by minus h. Okay. So this you will get limit h tends to 0. Modulus of minus h is h. And this, if you will take out minus common h plus 1, you will get, that means you will get the plus 1. So plus 1 minus 1 by h. So these two will get cancelled. It is limit h tends to 0. 2h by h. H will get cancelled. You will get 2. This is a denominator negative, no? So it is minus 2. If you will compare this one with the before one, first method, you got same one, RHD as 0 and LHD as minus 2. Similar way, you can see for even 1 also. Okay. If you have any conversion of converting the given function into, that is the 3 different functions, directly you can do with the help of the given function only. Okay. So this is the second method and first one is the first method. So you can follow any one method and you can solve the problems. So by this, we are completing the second unit. Tomorrow we'll see the third unit, that is the methods of differentiation. So by that, we'll complete the block 1. Okay, tomorrow we'll meet, students.